This video is going to go over graphing quadratics when they're in standard form. So standard form looks like this. You'll generally have like a ax squared plus bx plus c type thing. It's not that hard to do, but you do need to know a couple things. Look at this graph down here. The vertex would be -1, 6. There's something called an axis of symmetry. Axis of symmetry. And essentially what it is it's a vertical line that cuts a parabola in half. And so like this one, this vertical line has an equation of x equals -1. Basically, it's the x value of your vertex. So you need to know that going in because we're going to have to find the axis of symmetry for all of these in order to find the vertex. So let's just go ahead and get started. This first one, number 1 here. You have to go get the axis of symmetry. This is your first step. In order to do this, there's an equation. It goes like this. X equals -b over 2a. So you have to look at this equation, know what your ABC is, A, B, C, and then plug it into this equation for axis of symmetry. So in this particular example, when there's not a number in front of that x squared, it's a 1. So A is 1, B is 6. So it'd look like this. B is 6. Remember, have a negative right in front of it, over 2 times my A value, which was 1. So x equals -3 is the equation of my axis of symmetry. So it's going to get cut, basically, cut in half at this -3 spot. All right, now I can use this to find my vertex by just plugging it in to my original equation for these x values. So here's what I mean. Plug in -3. And this is to find the y value at this x value. So if you do this, -3 squared is 9, plus 6 times -3 is -18, plus 8. That's a value of -1. So now I know my vertex is -3, -1. Right there. Now, all you have to do really is kind of like what we did in the previous video. You could write your equation like this. Set up your equation where it kind of formats for the vertex. So what I mean is the x lies, so put +3, and then -1 on the outside. See, it identifies my HK. This is like vertex form. But you need to get your A value right here. This A value can be found from before. We already identified A. It was 1. So this is actually my equation in vertex form. Now I can use this to, just like in the previous video, set up an XY table using these parent function coordinates and just apply my transformations to the table. So the first transformation would be this +3. It's lying, so do the opposite, and it affects my x values. The second transformation would be this -1. It's telling the truth and it affects my y values. Now I can just graph it using these outermost numbers as coordinates. So like -4, comma 0. Then just connect the dots with the U shape. And that's it. So my A value is 1. There was no reflection. Since it was an A value of 1, there was no stretch or compression as well. In vertex form, it looked like this. The graph is right here. The vertex, this vertex, this blue dot, is the lowest on the graph. That means it's a minimum. And this graph opens upward. All right, just like that. Let's look at the second example. Remember, you have to go find your axis of symmetry first. So that looks like this. X equals -b over 2a. Identify your A, your B, and your C. Be careful, this does not say 8. It says -8 for my B value. So this one's going to be kind of weird. When you plug it in, the negative on top is there by default, so you have to write it. Then B is -8, so it's like -8 over 2 times A value of 2. This -8 part is like if it's becomes positive again. It's like a negative times a negative makes a positive, so like 8 over 4, which is just 2. So I know my vertex, the x coordinate is 2. Axis of symmetry, x equals 2. Now, you're going to have to plug in this x value to this equation to solve for your y value. So it looks like this. Y equals 2 parentheses 2 squared minus 8 times 2 plus 3. Solve this out a little bit. 2 squared is 4, times 2 is 8. 8 times 2 is 16, then plus 3. All right, when you do this, you will get -5. That's the y value of my vertex. So 2, -5 is my vertex right here. Now, you can basically write your equation in vertex form from here. F of x equals, my A value was 2 from this right here. Then you have to basically set up your own vertex. So remember the x lies, so I write x minus 2 squared. Then the y tells the truth, so -5. This is the equation in vertex form. I knew my A value was 2. Now to graph this, basically I set up an xy table using my parent function coordinates. Remember, these transformations here get applied in a left to right order. So this 2 goes first. It is timesing by 2 on your y values. The next one would be this x minus 2 part. It is adding 2 to my x values. Then the last one would be the -5. It's affecting my y values, and I do what it says. Now I have some coordinates that I can graph. And this one would look something like that. So the vertex, this blue dot, is the lowest on the graph, so it's a minimum. And this graph is opening upward. Okay. Now, number 3, I know you're probably looking at it and thinking, oh gosh, there's a fraction. That's okay, stick to the plan. Identify A, B, C. and go find your axis of symmetry. So x equals negative b over 2a. So negative b would be minus 4 over 2 times, my a value is negative 1/2. So this is like negative 4 over negative 1, which becomes positive 4. So I know the x value of my vertex is positive 4. My axis of symmetry is x equals positive 4. Now you have to take this 4 and plug it in for your x values here and here. So that way you can solve for your y value. It would look like this. Okay, do the math a little bit. 4 squared is 16 times negative 1/2 makes negative 8. 4 times 4 is 16, then the minus 2 at the end. So this one's going to become 6. So that's the y value of my vertex, 4 comma 6. Put a dot there. Now I can write this in vertex form because I know my a value was negative 1/2. So I just go like this, f of x equals negative 1/2, parentheses, the x lies, so I'm going to write x minus 4 squared, and then plus 6. So this is it in vertex form. Now I can make my table and use my parent function coordinates. Apply these transformations in a left to right order. So the negative 1/2 goes first. It is timesing by that parentheses. So you are timesing by negative 1/2. The next transformation would be the minus 4. So I'm going to add 4 to my x's. Then the last one's this plus 6. It's affecting my y values. So go and add 6 to these numbers. Now you can graph this line using these coordinates. Okay. So this vertex, this blue dot, is the highest on this graph now. So that means it's a maximum. And this graph is opening downward. And then this last one, write the equation in vertex form and then convert it to standard form. So to do this, first thing, identify your vertex. Your vertex is at negative 1 comma 6. So you can start writing your equation. Like that. The problem is there's an a value right here that you don't know. So you basically, all you have to do is pick any coordinate. I'm going to choose this one right here at 0 comma 4. This is an x, y value. That means you can plug it in for y and x here and solve for your a value. So it's going to look like this. All I did was I replaced f of x with what I wanted my y value to be, 4. And I replaced the letter x with what I wanted my x value to be, which was 0. All right, now just do the algebra and solve for a. So 0 plus 1 is 1. Square it, that's 1. So this is like it says 4 equals a times 1 plus 6. A times 1, just rewrite that as 1a. Now just minus 6. And you get your a value is negative 2. So I can just go back to my equation here. And where it said a, I'm going to change that to a negative 2. All right, now to write this in standard form, you're going to have to FOIL this out. If you don't know how to FOIL, go watch the previous video. But basically this x plus 1 squared goes first to the first. That's x times x is x squared. The outside is 1x. The inside is 1x. And the last is 1 times 1, which is just 1. Combine your like terms. All right, so that's just this x plus 1 part. So it's really like it says this. I'm going to replace x plus 1 squared with what I got when I FOILed it out. X squared plus 2x plus 1. All right, now you're going to have to do some distribution here. So it's going to look like this. And then don't forget you have a plus 6 at the end, and that's going to be important because you'll have to combine these like terms at the very end. So my final answer here would be f of x equals negative 2 x squared minus 4x plus 4. So that one was kind of tricky because there's a lot to it. Identify your vertex, which was here. Write you an equation based on that vertex, but you're going to have to leave this number as the letter A and go solve for it by using any coordinate. I chose 0, 4, but it would have worked with like negative 2, 4 as well. This is me solving for the A value there. Just plug in that 0 and 4 for your X and your Y value. Solve for your A. Once you have your A value, now they want you to take it to standard form. So you have to FOIL out the x plus 1 squared part first. And then you'll have to rewrite it because you're going to have to do some distribution and some combining like terms.